You ever click buy now on something and then, the very next day it's sitting on your doorstep? How on earth does that happen so fast? Well, it's not exactly magic, but it's pretty darn close. It's an army of incredibly smart robots. So, today we're going to pull back the curtain on these things called autonomous mobile robots, or AMRs, and see how they are the secret sauce making all of our instant gratification shopping possible. Right, so take a look at this little guy. This is an Amazon Kiva robot, and it is the powerhouse working behind the scenes. It, and thousands just like it, are quietly solving one of the biggest logistical puzzles on the planet, getting the stuff you bought from a random shelf in a massive warehouse to your front door at, lightning speed.
But to really get why these robots are such a total game changer, we have to first understand the huge problem they were designed to fix. It's a problem that's been a massive headache for warehouses for decades.
And that headache has a name: motion waste. It's a key idea in lean manufacturing, and it basically just means any movement that doesn't actually get work done. In a warehouse, that means people walking and walking and walking some more. We're talking miles every single day just to get from one item to the next. And here's the crazy part. In a traditional warehouse, the pickers, those are the folks actually grabbing your items off the shelf, they can spend most of their time just walking around, not picking, walking. And that's not just inefficient from a business standpoint. As the research points out, it's physically draining for the employees. So, with this massive problem of wasted time and energy, the stage is set for our hero to enter. Engineers needed a whole new kind of worker to fight motion waste, and what they came up with was the autonomous mobile robot. Now hold on, because not all warehouse robots are the same. The older tech, these things called AGVs, they're kind of like trains. They have to follow a fixed track, like a magnetic strip on the floor. If something gets in their way, they just stop, dead in their tracks. But AMRs, they're the new way. They're way, way smarter. They use sensors to build their own map of the warehouse and make decisions on the fly. So if a person or a box is in the way, no problem. They just figure out a new way to go. So how do they pull this off? Well, you can think of it like giving them a set of high-tech senses. We've got their eyes, that's the LiDAR sensor you see there, using lasers to paint a 360-degree picture of everything around them. And then you have the brain, a super powerful AI chip that processes all that visual data and makes decisions in a fraction of a second. Okay, so you've got the eyes and the brain. Now the AMR is ready to tackle the controlled chaos of a warehouse floor. So let's get into the software, the code that actually powers its thinking process. The main technology here has an awesome name: SLAM. It stands for simultaneous localization and mapping, and it sounds complicated, but you actually do it all the time. Think about it. When you walk into a room you've never been in before, your brain instantly starts building a mental map of where everything is, while also knowing exactly where you are inside that map. That's SLAM. These robots just do it with lasers and a whole lot of math. And having that SLM capability is what lets the robot handle the unexpected. So let's say a box falls into an aisle. What happens? Well, it's a simple four-step dance. First, it senses the box with its cameras or LiDAR. Then it analyzes it to figure out what it is. In a split second, it plans a brand new safe path. And finally, it executes, driving right around the obstacle and continuing on its mission. Simple as that. All right, one smart robot that can avoid boxes is cool. But a real modern warehouse has hundreds of these things zipping around at the same time. So, how do you keep them from just becoming one giant chaotic traffic jam? Well, that's where you need a kind of collective intelligence. You basically give them an air traffic controller. This is what a fleet management system looks like. It's this central brain, this piece of software that has a god's eye view of the entire warehouse floor. It tells each robot what to do, it manages traffic at busy intersections, and it even knows when a robot's battery is getting low and tells it to go find a charging station. But here's the thing about managing a fleet. It creates this whole new challenge. It's sort of a Goldilocks problem. If you have too few robots, orders start piling up and getting delayed. But if you have too many robots, they just get in each other's way and create robotic traffic jams. So the whole goal of that fleet management system is to find that just right balance to keep everything flowing perfectly. And the future of this hive mind is honestly even cooler. Researchers are starting to move away from having one single central controller. The next step is a decentralized system where the robots actually talk directly to each other to coordinate their movements. It makes the whole operation way more flexible and resilient, If the main computer goes down, the work doesn't just stop. So, with all this talk about autonomous robots and hive minds, you might be thinking, okay, so where do the humans fit in? And that's a fair question. But this isn't really a story about replacement. It's actually a story about collaboration. This really lays out the massive shift in how the work gets done. The old way was picker to parts, where the human worker walks for miles to go get items. The new way is parts to picker. The robot does all the traveling, bringing an entire shelf of stuff directly to a human worker who stays in one place. This lets the person focus on what humans are still way better at, the tricky task of seeing the right product, picking it up, and placing it carefully into a shipping bin. And this quote from one of the research papers just sums it up perfectly. The key word here is assisted. It's AMR-assisted picking. The robots are taking on the most boring, the most repetitive, the most physically exhausting part of the job, all that walking, which frees up their human coworkers to be more productive and, frankly, a lot less tired at the end of the day. So, what does all this mean for the future? Well, this new model of human-robot teamwork is changing absolutely everything about how a warehouse operates. But it also brings up some really important new questions we need to think about. And that brings us to a really interesting gap in what we know. This chart here maps out all the different things researchers study when they look at warehouse systems. You can see things like efficiency and speed, throughput, and lead time are studied a ton. But look at that box for human factors. It's one of the areas we seem to know the least about. And really, that's the big final question this all leads to. We've become absolutely brilliant at engineering the perfect, most efficient robot. But as these machines stop being just tools and start, in a very real sense, becoming our coworkers, the next great challenge isn't just about building a better robot. It's about designing a better way for humans and machines to work together.